Your journey has been fueled by a vision. How important is it to have a vision?
Can't say I ever tried to put a vision into words. Let's try to do new things, not just little improvements, but a significant improvement that if we can make it work, could make a difference. And then the other thing is being able to take an idea and go from a concept to something that's real that people are making use of. There's a huge amount of excitement in that. So being able to be excited by you start with an idea and it turns out really to have an impact.
Hello, everyone. This is San Diego Computer Science. We are the San Diego Tech Incubator for college students. Today, I'm accompanied with my co-host, Victor Fougere. Victor, who do we have the pleasure of speaking with today?
Hello, Jeremy. Today, we're speaking with none other than American electrical engineer, entrepreneur, philanthropist, founder of Qualcomm, Dr. Irwin Marc Jacobs. So tell me, Dr. Jacobs, what led you to the field of engineering and how did it lead to the business opportunity to found Qualcomm?
Well, it was a roundabout route, actually. I was always interested in science and engineering growing up. Of course, that was before the time of computers or cell phones or any of the technology. I graduated high school back in 1950, so it goes way back. I was always interested, though, in math and science and engineering and had a lot of projects of my own, including a photo doc room, and I did some commercial work of that sort. But my high school counselor at New Bedford, Massachusetts High School at the time said there was no future in science nor engineering. A little bit incorrect. And as a result, asked, what other areas might I be interested in? And my folks had a hotel had a restaurant at the time. So he said, well, perhaps you should think about Cornell School of Hotel Administration. So actually, I started my college career at Cornell in hotel administration and was there for a year and a half before I switched over to engineering. And I must say it was some useful aspects to it because I had a whole year of accounting, which has turned out to be quite useful. And also half year of business law, which also turned out to be useful, although at the time I didn't quite realize it. But decided to switch during a Christmas vacation, actually following a discussion with a couple of my high school teachers, switched back over to engineering. I often say it was partly because I had a roommate who was an engineer and always claimed you couldn't possibly get those grades if you were in engineering as opposed to the hotel school. In any case, spoke to the dean of students about switching, took 20 minutes or so to convince him I wanted to go from hotel to engineering, not the other direction, and did make the switch. Always took a kind of heavy load of courses because I had a half year to make up. I lost the year and a half in hotel, but I had a half year to make up in engineering. And I also decided to go engineering co-op, which was a program where every other term go out and work in industry. In my case, Cornell Aeronautical Labs out in Buffalo, New York. In any case, so that gave me some feel both for things that are going on outside the university as well as within. Getting ready to graduate. I probably should indicate that I met my wife sophomore year. She graduated, of course, 4 years after starting, so in 54. And we married in September after her graduation. And then she supported me for several more years after that as I went through my schooling. In any case, I was thinking about going to work immediately after bachelor's degree, but a couple of the engineers I worked with at Cornell Aero Lab said I really should apply at least to one university. So I did apply to MIT and applied for a General Electric National Fellowship. And luckily, they both came through. And so off I went to MIT. thinking I would study electromagnetic theory because I had some good courses on that at Cornell. But it was the time of great interest in information theory because Claude Shannon, the father of information theory, just was coming actually the same year that I arrived to MIT. And so I switched over to communication theory and information theory. And of course, that has worked out quite well. Completed my master's and then stayed on for the SCD, actually, a selected science doctorate at MIT, and then was invited to stay on to teach. And so I joined the faculty and spent 7 years teaching, which in a sense is by far the best way to learn any material, is to go ahead and teach it. The part of that time with another professor, we started a new course in communication theory and its applications. And from the text that we had to put together, hand out to students, we wrote a textbook, Principles of Communication Engineering, which ended up as the first textbook in the field. Still of interest. There's a lot of good material still in it. Any case, I decided just after completing the book that it might be good to take a year's leave. Had an invitation to JPL to do a NASA Resident Research Fellowship there. We bought a used old van. We had 3 children at the time. This was 1964 summer. And we took 3 weeks camping cross country, which was really quite an interesting experience. Worked out well, lots of national parks. And spent 9 months out here in California. Got to love it. Traveled up and down, discovered San Diego. Thought, well, it might be nice to retire here sometime. And camped back up the coast of Vancouver and across Canada and Trans-Canada 1. Arriving back in Cambridge, probably within a few weeks, had a call from a former professor from Cornell. Would I come out and teach at a brand new university? All our family, friends, everything's on the East Coast. So even though after a visit out and still liking San Diego very much, we turned it down. But for the next couple of days, we're kind of unhappy with that decision. We thought we really would enjoy California. In any case, second day, I often tell the story, heavy rainstorm, met my wife soaking wet when I came home, and she immediately told me about a contemporary home and read a description. We'd been looking for a house around Boston. I said, great, let's go see it tomorrow. She said, only one problem, it's in La Jolla. And that was enough to flip us. So called up and said, if it's still open, we've changed our mind, we will come. Out we came to La Jolla, camping cross country once more, actually with a newborn infant. So we had 4 boys at the time. Came out, it was great fun teaching at UCSD, a public university, putting curricula together from scratch. First students didn't graduate for a couple of years. So building undergraduate programs, graduate programs, et cetera. So that was quite interesting. But I had a number of friends who, well, backing up a second, because of having published the textbook, there were a lot of requests for consulting. And I would consult typically a day a week. But I mentioned that to a couple of friends from UCLA faculty. And they said, well, let's start a company and share consulting. And so started Linkabit, which was the first company. We actually made the decision in 1968, but didn't really get active for another year or so. I still kept doing most of the consulting anyway. And however, there was a lot of interest. It began to grow. Had to hire a couple of people. And again, this was starting a business with no real business plan, and no products obviously in mind. But it began to grow. And I decided I better take a year's leave from teaching and get it organized, which I did. And after that year was over, I had to make a decision whether to retire from the university or go back to teaching, which was, of course, attractive. But for years, I've been telling everybody that taking very theoretical subjects really did have a payoff, that they would be useful in the real world. And so going into business would be one way, if we could develop such products, one way of demonstrating, yeah, well, this theory is really very good. And so we decided to stay and build Link a bit. The company grew every year. Interestingly, for the first 9 years, it was largely doing government business, because at the time, if you had a very good idea, you could kind of suggest it to NASA or to other government agencies, DARPA in particular, and get a fairly quick response back. And if they like what you were doing, you could, they'd send you money, progress payments. And so the financing was a lot more straightforward. So Linkabit grew 50–60% every year and was profitable every year. And kind of developed an approach to how to run a company at that point, in that because of the academic background, it's good to have a very open company, lots of discussion, bring in people with new ideas and kind of look for new ways to doing things. So the strategy was to never look for something where it'd be a small improvement, but is there something we could do that would be more substantial? First major project, for example, was an Air Force program. And we had started working with another company. The other company got eliminated, and but the Air Force wanted us to keep going, because we come up with this idea of using a microprocessor to do almost all of the communications within the satellite terminal. And at that time, of course, there wasn't single chip microprocessors, but there were several chips you could put together and make a processor. And then you needed memory, and memory was, you still could get on chips, but not very much per chip. And so we had to come up with a way of having a computer that would work well in real time, but with a very small instruction set. So we came up with the first, what they call RISC processors. You may have studied them, reduced instruction set computing. Came out of Berkeley about 10 years later. They might have been working on it previous, I'm not sure. In any case, so we went ahead and designed, won the contract, designed a satellite terminal using this. So another one of my favorite stories was, it came time for the Air Force to make a decision between, well, who would manufacture the final product, going a production contract. And to get that production contract, we needed to get one more contract, because there was a bunch of classified information we had to include along with the production contract. And went up to see the commanding general, who was up in LA, and he started out by saying, yes, I know your project, but your competition is another major company, and we've worked with them for years, and they may not meet all the specs, but they come through. So I thought he was about to dismiss us. And then he said, but as a taxpayer, I'm going to give you the contract because it has some potentially great advantages. In any case, he did. We won the contract and went into production, building many of these units. As far as I know, they may still be flying. Another interesting aspect was because it was microprogrammed. Lincoln Laboratory from MIT came to us and said, could we design it to talk to the Lincoln experimental satellite 8 and 9, LES 8 and 9, which they were preparing and going to launch. And they gave us some handwritten notes on what the communication strategy is for the uplink, for the downlink, coding, and various other details. And so we added that programming to our, we called it the dual modem, to our dual modem package. Turned out that we suddenly got a call one day, could we bring our terminal to Lincoln Laboratory back in Bedford, Mass, because they want to do a test of it before they ship the satellites off for launch down at Cape Kennedy. And ours wasn't quite ready, so we had to spend about another 2 engineers, myself, about 30 hours full-time finishing the coding, checking it, making sure it was ready to go back. Carried it back on my lap on an airplane, ended up at Lincoln Laboratory just before their lunchtime. So they said, well, maybe we ought to go to lunch. I said, no, at least let's test the uplink. We did that, worked like a charm, went for lunch, came back to test the reverse link, and it didn't work. And so we began to try to figure out why. It turned out it was Lincoln Laboratory had misread its own handwriting on a matrix, and so that had to be fixed. In any case, fixed that, everything worked. And so that was kind of a fun aspect. They did go ahead and launch those satellites, and turned out Lincoln Lab had never gotten their own modem to work. So without ours, they would have never been able to test the satellites in advance. So that was kind of one of the things. Lincoln, we did the first of these small aperture Earth terminals. They back away they used before the internet, used to use the gas stations to send back credit card information. We work with Walmart to outfit all their stores and their warehouses so they could exchange information back and forth. So it turned out to be a very successful product. And we got involved with another one, which was a satellite to home. These were all competitive contracts you had to go and win and then proceed with. Was HBO wanted to scramble their downlink signals to the cable heads so people couldn't get them for free. And so we came up with an approach to do that. Then we bumped into our first political problem. A group of people that own base stations went and asked Congress to forbid HBO from doing it unless they had a home unit that they could get. And so we suddenly had to develop a home unit. And to do that, we had to develop 3 integrated circuits. And the technology to do that design on computers was just getting finished at Caltech largely, but also MIT. And we had done some software at Lincoln. In any case, we put that all together. And luckily it worked. We ended up with 3 chips using a program where you could get a part of a wafer to put your experimental chips on to check them. And so that worked out, and then we went into production. And so all that kind of was causing the growth of the company. But we had another issue that we were, as a small company, always giving out stock options to all the employees. And I think, saying, okay, we'll try to be competitive in salary, but as far as your estate's concerned, that if we're successful, the options. But you couldn't cash them in any way when you're a private company. And so the question was, how do you go public? We thought about going public ourselves, but it wasn't being done very much at the time. So we did merge in with a New York Stock Exchange company, Maycom. And for a while had the highest multiple on the New York Stock Exchange for a few years. Then there were some executive changes in the parent company, and so I figured it was getting close to the time to leave. So I did retire in '85 from Linkabit. Spent 3 months deciding what to do next, go back to teaching, venture work, or another company. And at the urging of some other Linkabit people I'd been working with, I decided to start Qualcomm. And so that was in July 1st, 1985, started Qualcomm. Again, no product in mind, new digital, new wireless would be useful. But other than that, I told my wife, even though Linkabit had grown a huge amount, I said, don't expect that again. We might get to 100 employees. We missed, which I think is 50 or 60,000 now worldwide. And so we started the company, thought, well, just like Linkabit, maybe it would start largely with government programs, but the government procurement system was and still is in kind of a mess. And so you'd send in a good idea and it'd take a year before you heard anything back. So that wasn't a good way to proceed. Did get a contract to develop a satellite communication system for the trucking industry from another company. And came up with actually using some of the EM theory that I'd gotten back at Cornell, how to design an antenna to go on a truck that would be rugged and cheap and be able to track the satellite as the truck drove around. So I did come up with that idea. And we did build the terminals. And before that, however, I'd come up with the idea during a consulting contract for used aircraft on a mobile satellite system, come up with the idea of using CDMA as opposed to more traditional TDMA and FDMA for the communication, thinking that with that, when people aren't talking, others can use it, and it's a statistical issue. As long as on too many don't use it at any given time, it all works really well. But you get an increase in capacity. In any case, we had done that, tested the ideas, come up with several other ideas, but didn't have the money to pursue it until we got our first large contract for this Omnitrax satellite, trucking satellite communication system. And then went immediately back to CDMA, which is interesting because the case study for Qualcomm is often done at Harvard and Stanford and other school. And usually the students get led up to a decision like that to make. Do you bet the company again, or do you play it safe? And the usual decision is to play it safe, but we didn't. And we decided to go ahead and try CDMA because it sounded like a great opportunity. And the cellular business was just beginning to grow. First generation of cellular was basically like FM radio, analog technology. But to get quality, get higher capacity, one needed to go digital. And so the industry was debating which way to go. In any case, we developed the CDMA ideas and immediately began to look at using it once we completed. This was roughly October of 60. We started the company in 65. This was 68. Went over to look at using CDMA and cellular, convinced ourselves it looked positive, had to proceed ahead to convince the industry. And it turned out that although we started in October to look at CDMA in January 69, the industry voted on which way to go, and CDMA got thrown out very quickly because most companies, too complicated, not enough gain, don't know how to do it. And so it was between TDMA, time division, and frequency division, FDMA. And the industry voted in favor of TDMA. And so they were off and running in January. In about March or April, we went and met with the local cell company and talked about CDMA. It had a potential economic advantage of much greater capacity. And so TDMA might give them 3 times the capacity of analog per antenna per megahertz. And we looked like we could get 10 to 20. And so that was enough of an incentive to get them interested. They did sponsor a talk that I gave back in Chicago to 120 industry people. And I've often said I assumed that there was a high probability somebody was going to point out a mistake that we had made and why this wasn't going to work, but nobody did. But nobody was convinced either. And so we had to go ahead and, in the usual startup mode, work day and nights for several months to build a demonstration system, which we did, and then invite everybody back to hear CDMA. And so the mobile phone, of course, took a van to drive it around, but so be it. In any case, people were convinced. Some of the operators, a few of them got excited and were willing to provide some support. But we had to go ahead and develop chips to build phones that were commercial size. And that was going to be an expensive proposition. And so came up with the idea that perhaps we should set up a licensing program where we license manufacturers who wanted to continue to serve the carriers who were interested in CDMA, license them to be able to use CDMA when it was working. They would give us an upfront fee, which would give us some of the money for doing the R&D, and then later pay us a royalty on the phones, which nobody paid too much attention to because very low probability that was ever going to happen. And we took a position, by the way, that it would be a low royalty rate because we wanted to, if we were successful, have a very large number of phones worldwide. Another decision we had to make fairly soon while we're going through this, so we had to go on and continue to raise some money. Company almost went bankrupt a few times then, almost also in developing OmniTrax. Any case, so you have to be prepared to take your belt in, tighten your belt with new young companies. Any case, we did develop the chips, and we brought everybody back for a demonstration. We now had a commercial size phone, commercial size base station equipment. Sounded great. They decided to have a cook-off, in a sense, compare us with the TDMA phones and anything anybody else might want to propose. And we did that in a large meeting in Dallas. You can see all these are riveted in my mind. There were such important steps at the time. In any case, we prepared some videos of what the radio waves looked like as we drove around, and also recorded the audio and some very good audio equipment so you could hear the quality on both ends of the call. And we took that back with us to Dallas. The TDMA people came up. Now, this was presumably commercial equipment and commercial operation, and they played their audios and they sounded terrible. A lot of static, a lot of dropouts, etc. And then we played ours, sounded great. So that convinced the industry at least to perhaps have a second standard for CDMA. We had to decide whether to in fact go through a standards process, but if you want to have equipment that can be built by many manufacturers and be internationally accepted, you need a standard. And so we decided we'd enter the standard process. It took another 1.5 years, was successful. And so we then began to look for commercial opportunity. The first system to go commercial was in Hong Kong. And so it was the beginning of the fact that you had to go and work internationally if you're going to spread this technology in a very successful way. Why Hong Kong? Well, at that time was still very poor. So most companies, people had their offices on the street and used their cell phone for their office communications. And so the spectrum was heavily used. And so something that would free up spectrum, get more calls in the spectrum, was very valuable. So they decided to go with CDMA. The only ones who would make phones at the time was Qualcomm. And so we ended up in the commercial phone business here in San Diego. Bought our next biotech factory where they had gone out of business and fix it up to manufacture phones. Shipped them off to Hong Kong. The next two to go commercial companies were in South Korea. And that was because we had visited South Korea a number of times in the early 90s and said, look, commercially, you know, you're always behind Japan. Japan is develops the product sooner. You can only get to them later and therefore compete only on price. With CDMA, you could be ahead of them because Japan decided to follow the US early standard and go TDMA. And so that convinced the government to at least urge some of the companies to work with us in a national research laboratory. In any case, so that resulted in the next two companies in South Korea going with CDMA. I might mention that Samsung fought us on that CDMA decision. And at the time, they and LG had almost zero cell phone business because it was all monopolized in the European manufacturers plus Motorola. And so this was the way they actually ended up breaking into cellular, even though they kind of fought it for a little while. But once the government said go, they went. And so we did get in there and then back into the US, both in the cellular business and the PCS business. Now, the other thing I often tell budding entrepreneurs is that they really have to be able to take a few arrows in the back, because if you're trying to do something new, you're always going to get people that tell you why you're wrong. And we had no lack of people telling us why we were wrong. And actually, after the first few systems that had already gone commercial but not really grown and proven themselves, there was a big article in the Wall Street Journal front page why my hype was misleading operators and they were going to waste billions because they were waiting for the CDMA and, you know, wasn't going to really solve the problem. And I did write back a letter to them explaining why I thought they were wrong, but they wouldn't publish it. One interesting thing, I went to a meeting in Paris about a month after this article of industry people. They all came around and congratulated me for having this article in the Wall Street Journal. I don't think they read it. They just saw the name Qualcomm and great advertising. Any case, we did go ahead, obviously, and build up. And the second generation was a big battle. Took us, for example, 9 years to convince the Chinese to go ahead with our technology, CDMA technology. Had a couple of hiccups. I won't go into all the details, but one problem in China is to convince them that they're willing to give you a large market. You have to give them the technology or work with a joint venture company there. We don't want to give away the technology. We had to argue with them that the profit was not only the market, but we had to be able to make a profit on the business as well. In any case, we eventually did get in there. Again, a story I often tell is be careful of Wall Street analysts, because at that time it was kind of not unanimous, but almost so, that why had I wasted 9 years trying to get into China? They already had, I don't know, a couple 100 million subscribers. That was the total middle class. And so there was no market left over. Luckily, that turned out not to be the case. It's been a great market ever since. Getting into India was a similar, every one of these countries has its own issues. getting back into Japan, getting them into CDMA as opposed to TDMA. But what eventually happened was the industry realized that one needed to go and have internet, high data access at a reasonable price for your mobile phone. And we started working on that in the late 90s. The industry decided they needed a third generation that would support both voice and data. We had already been working on it. The TDMA people began to work on it, eventually realized that CDMA was a much better way to go. So ultimately, the whole industry went CDMA in the third generation, and that got past those arrows in the back part of the business. People referred to that period as a religious war, which it almost had those characteristics. In any case, one other lesson is, even though you have a very good technology and things are growing, you have billions of users out there, one of the things we had to decide very quickly was strategic direction. And we decided that our real strength was in technology, continuing to develop the technology, and then bringing it to market, not as phones and infrastructure, but rather as chips and software. And so we sold our infrastructure business to Ericsson. We sold our handset business and focused in on chips and software and technology licensing, which has been the mainstay of the company since. And as a result, we pressed what are called horizontal business models. We worked with companies where they would do the plastic for the phone and add some of their own software, obviously, and ultimately cameras, etc. And we would provide the chips and software so they could get into the business fairly quickly. And so we did that and built up large numbers of manufacturers, including many in China. China took a while to get into the third generation because they tried to develop their own form of CDMA, but that ultimately didn't work out, and they went with ours and WCDMA. And so then the question really is, people are coming up with new ideas. You're going to stay with what you have, that's a great business, or should you continue to press ahead with new technology? And we decided to do the latter. And so we've gone through a fourth generation now into a fifth, and looking ahead to a sixth generation. So one needs to continue to run ahead with these. Another interesting aspect, back when we began to realize that we're going to be able to get high data rate communication with the phones at a price the operators could get customers to buy, was how do we get enough computing power and capability in the phone? So we began to look at different possibilities there. We actually set up a facility in Research Triangle Park, hiring a number of people. IBM had just laid off who were in the CPU business at IBM. And we hired them and looked at how do you get a lot of computing power but use very little energy, because you have to run off a battery. And so we developed a number of very good techniques. And even though we started with complex instruction set computing, actually using some Intel technology, we quickly switched over to reduced instruction set because we could get by with less energy usage. And ultimately, actually, ARM designed some chips, so we began to use their technology, although we implemented it in our own way for a while. And so that began to grow. But then what other things are there out there? Well, position location, the GPS satellites were getting up there. And so we put that on a chip. That turned out to be controversial also, because many manufacturers wanted to use triangulation of base stations to locate it, claiming China would never let GPS in because with US military technology. That didn't turn out to be the case. They were very happy, ultimately launched their own system, as did Russia. So we use everybody in Europe you use everybody's systems there now. But in any case, we were the first to really get GPS on a chip and began to push location services. We got involved with obviously putting cameras on the phone, although everybody's reaction early on was, why would I ever want a camera on my phone? And it really took a while until a very good user interface was brought up by Apple, in 08 or so on the iPhone, where people realized they could do multiple applications on the phone and not have to really work too hard at it. And that really was a great breakthrough. So that greatly expanded the capabilities of the phones, and it's been growing very well ever since. One other aspect we got interested in early was, okay, now there's getting to be billions of these phones around the world. What are the good applications socially might they have? Education, medical uses, people's work. And so we came up with approaches for fishermen to use, farmers to use, medical uses in remote areas. And that's still, of course, an ongoing and major growth area for the whole industry. And so it's been interesting. Of course, now I retired, by the way, as CEO in 2005 on the 20th anniversary of the company. But it's continued to move ahead and continued to do lots of things. So, of course, a lot of the interesting applications these days has to do with self-autonomous vehicles. And so Qualcomm has various offerings and getting some interesting work with a variety of the automobile companies. Drones are interesting, robotics interesting. And so these days, when someone asks me what the most unexpected happening from Qualcomm might have been or is, it's that there's a helicopter on Mars that's still actually flying around, even though it wasn't expected to last very long. And the chip that provides all the intelligence, communications, and photographic capability is a Qualcomm chip. So whoever thought we'd end up with a chip on Mars? Any case, so it's been an interesting experience. Long answer to a short question.
So you mentioned so many different applications and the ubiquity of Qualcomm products. And you also mentioned kind of all these different scenarios of experiencing doubt, whether it was in the beginnings of communication theory and not many people seeing the highly practical application to a highly abstract concept. And then later on with the industry doubting CDMA over other technologies, and then you guys betting the company. How do you see how doubt has fueled your career? Because you could have gotten scared at the first step and had a completely different trajectory. How do you manage to lead yourself to where you're at with all these things that didn't appear to have gone in your favor at the time?
Well, first of all, being an engineer has a great advantage. So you can understand some of the technology, is there some theoretical issue that you might be bumping into? So you can think about different approaches and then try some new approach. So have to be very open to change and taking the larger step. But I often say you then apply the 4 a.m. test. You wake up at 4 a.m. thinking about the problems. You go through all the issues people have raised and that you've raised yourself, et cetera. And if you still can go back to sleep, stay with it. So you often have to take risks. On any risk, you have to look at the upside. You have to look at the downside, and then what are the probabilities and is it worth going ahead? With the cell phone business, that was quite interesting because you began to look for the upside and the numbers were crazy when you're still a small company looking at it. And so I'd often say, well, we'll divide by 2 and divide by 2 again, and we'll divide by 2 a few more times and then build a business plan. And of course, the industry actually ended up with all those 2s being real.
Interesting. So you didn't do the whole Qualcomm business by yourself. You must have had a lot of collaboration from different people. Victor and I are study partners, and I would consider us business partners as well. Was the attributes that you look for in business partners or people that you're going to embark on long-term journeys of developing products or services or large businesses?
Right. Well, the link of it was a little different because I started with 2 other people who were interested in starting a business, faculty members at UCLA, one of whom dropped out pretty quickly. In the case of Qualcomm, there were 6 others from Linkabit. After I left, they kept talking with me. Let's do it again. You know, there's still exciting things to be done. And I knew those people, so I knew I was comfortable working with them. And so I had already had some experience with those people. But you need people that, first of all, are willing to come up with ideas, aren't going to let you say something without challenging those ideas. You want to always have someone you can have interesting discussions back and forth. You want people that are first also honest. Honesty is really crucial to everything you do in life and obviously in business. And so that's and I also like to have people who are empathetic, that actually are concerned about other people's feelings and the impact. And that's even true when you're negotiating contracts. The other side is trying to get things that it appeal to it needs. You have your own needs. Don't try to crush them, but try to find something that's going to work well for both of you if successful. So empathy is another aspect. And ambition, interest in really looking at new things, trying them out. Often, you know, somebody that's gone through a school program and worked hard to actually move ahead in that program indicates they're capable of hard work. So we're always looking for people that are willing to do that hard work. And of course, in any startup business, very quickly you run into crisis. You have to work several 24-hour periods to get through the crisis, et cetera. And so being willing to do that while finding a reasonable life-work balance, that's the other important thing. You don't want to be breaking up families one way or another. By the way, one of the things at Linkabit and Qualcomm, we were always hiring lots of very young people as we grew, and we were growing rapidly in both cases. And so most were straight out of college, and then they'd meet, and so we ended up with lots of married couples over time, and they'd bring in family. So we were never against that. Our only constraint was that you couldn't have 2 relatives, one working for the other, that they had to be in different areas. But other than that, it was fine. And I often talk about, you know, you go ahead, you build, you don't think about it, the responsibilities too much, other than how do you keep things going properly. And I remember we used to have a summer picnic. And there was one time when Qualcomm had grown to a point where we were taking up the entire athletic field at UCSD for our picnic. And we got there a little late and looked down, and this huge crowd of people, families, kids, you know, the whole, and you begin to feel a sense of responsibility at that point for sure.
Obviously, your journey has been fueled by, I would say, a vision or goals. And how important is it to have a vision?
I can't say I ever tried to put a vision into words, and other than the strategic approach, saying, let's try to do new things, not just little improvements, but a significant improvement that, if we can make it work, could make a difference. And so we're always looking for those larger steps. And then the other thing is to, where does satisfaction come from? Satisfaction really comes ultimately, it's not from the financial returns, because we often can very quickly get to a point where, we don't really need anything further. But being able to take an idea and go from a concept to something that's real, that people are making use of, there's a huge amount of excitement in that. So being able to be excited by, you start with an idea and it turns out really to have an impact.
Where do you see the future of chip technology? We see that different legislation has been passed in Congress with the onshoring of semiconductor manufacturing. We also have seen the uprise in commercial use of artificial intelligence. Where do you see the future of Qualcomm and chip technology?
Well, of the industry in general, but with any company, you have to keep running. If you slow down at all, people go past you, and that's not a good thing. And so you have to keep running. With the legislation, there's been some focus on investments in companies to have them set up their foundries here in the U.S. I think the real limitation that these companies have the resources. They're continually adding up the new update to get to the next generation on Moore's Law, although we're running it toward the end of it at this point. What they need are trained people. One of the things that Taiwan did very well was to build up training programs at a variety of levels. And so even as the companies grew and they needed more and more people, the universities and the training schools, technician schools, whatever, community colleges, were turning out the people that they needed. And so I think a significant amount of the funding should go into training programs at universities, community colleges, wherever, encouraging companies to bring in people to intern, whatever it would take to build up that workforce, because we really don't have that workforce at this time.
How would you advise young engineers like me and Victor and everybody in our organization? How would you advise us to go about the changing in the industry? You mentioned different training programs. Is there specific things that you see are beneficial to learn in the long term for young engineers? And also, what advice would you have given to yourself if you were an electrical engineer, but you were an electrical engineer in 2023?
Well, the world obviously has changed greatly since I graduated back in 1959 from MIT. And it's however, it has many of the same characteristics in that we're going through a period of significant change. Transistors, Moore's Law had not yet been postulated. When he did do that, it was on a 1 year, doubling every 1 year. It turns out that it's almost perfectly every 2 years. But in any case, the one thing to recognize again is get a good education suitable for yourself, whatever your interests are. But a good education comes first, but then be open to change, because the world is just going to continue to change rapidly. And so the thing to do is to read a bit, to talk with people a bit, to get a feel, hey, here's a problem that's bothering a lot of people. And maybe we can think of a good solution for that. And so if you have a good background, some people that talk and bounce ideas around, be prepared for that change and find a way to take advantage of it. As the company grew, one of the things we continue to look for, again, are new ideas. But I often would tell Qualcomm employees as we were getting more successful was we have to work at continuing to think of Qualcomm as a small company that's come up with good ideas and make sure people understand and consider them. But the great advantage of Qualcomm is we have a great cash flow. So you have a good idea, we can support it. But again, the specific direction, and it's going to change every few years, I would say, it's looking beyond 5 years, particularly now with the great advances in AI, the change is going to be even more rapid. Should you learn, for example, different programming languages and spend a lot of time at that? Or is a larger amount of that going to be done by AI? And should you try to then think about how do you take the code that it gives you and decide where the bugs are? And so the challenges are going to be changing. And how do you get some AI that does that for you? So this is going to continue. On the hardware side, clearly there's been great need for chips that can handle the learning requirements. There's now a realization that we better be able to do that and use very little energy per chip, per computation, whichever. So it's going back to the cell phone directions. Qualcomm did at one point begin to work on AI chips, but then during one of the downturns, cut that program, which I was always sorry about that was after my time, but I was sorry that they didn't pursue that. But anyway, I think there's always on both the engineering, the chip design approach, new approaches to be followed that can make a difference. So we continue to need engineering folks. We're going into whole new frequency bands, and so even the RF engineering, the EM theory, all these things still end up being pertinent. And so kind of getting a reasonable broad variety of background during your education, as well as going deep in one or two areas is important. I think the AI, the whole area, and autonomous vehicles, autonomous airplanes, autonomous whatevers, more and more of that coming along. And so at some point, we're going to have to worry about how do we best use our time, because I'm convinced that we're going to be more and more productive. These things all take time to see productivity go up, but it happens. And at some point, we'll be able to support all of our service needs and hardware product needs with a smaller number of hours worked. And so I see our work weeks shrinking to 32 and at some point below that, perhaps. And so one needs more time, some more activities that will keep you interested. Some of those are cultural, some educational, some just going off and sitting in the sun for a while, which raises some more medical problems. In any case, we are going to have, I think, not us, but next generations, your generation slightly, and then beyond, more hours of the day to think about what are the other things that you're really interested in doing. And part of that is education. You always want to try to, okay, what's the next interesting thing? How can I pursue it? And so the intellectual life will always be interesting. And so one of the things we have supported quite a bit are some of the cultural activities around the city. partly because employees, the company enjoy them and helps attract new employees to the company. So that was my justification back in when I was still corporate. And by the way, arguing with shareholders that if you make your employees a little bit happier, they tend to stay with the company, and that's a huge financial incentive. So it certainly justifies making some charitable contributions. In any case, having a broad area of support in the community and making the community itself more interesting.
Obviously, Dr. Jacobs, you had a storied career with Qualcomm and all your other work. And that leads me to the future and legacy. What would you like to be remembered for, and what would you like your legacy to be?
Well, first of all, that the work that we did has led to a much better life for many, many people around the world, and has in fact directly involved employment for many, many people, and has provided interesting work. So that whole progression of starting companies, building it, coming up with new ideas, getting those to market is one of those legacies. Another one is just the example of taking an idea and running, even though you end up with a lot of negativity out there. People don't want to make changes sometimes. And so that as long as you can persuade yourself that you're on the right path, you make changes of direction as appropriate going along, but you continue to pursue it. That is a legacy that that having done that, a legacy that others could look at and follow. And finally, philanthropy, I think, is an important one, giving back once one is able to do so. And by the way, also paying attention to the political scene. People we're talking about here often have very good educational background and also often an understanding of technology and science. That some of that should be brought to the political side. I mean, politics are awfully difficult. You've got people with very differing opinions, and to convince them that for example, the climate needs great attention, it takes people with the proper training and then ability to go out and work to make that happen, to tell people about it and convince them that yes, you have to make a short-term cost, have a short-term cost for a long-term advantage, that be able to look ahead like that. So the educational aspects, I think, though, that we all have, I think that's important.
Awesome. And obviously there has been a ton of positive side effects from this impressive leap in technology. What are some, in your vision, what are some negatives?
I think any technology has its positives and negatives. We, by the way, at Linkabit did the very first real-world demonstration of the internet protocol with one network that we had designed for taking the ARPANET over to Europe, plus the ARPANET plus one other network, and ran data over all three, each one of which had different network protocol, but using the internet to tie them together. So that ended up being an interesting time period. What did you ask me again? I'm sorry.
Oh, the negatives of this.
The negatives, yeah. On the technology. So the internet obviously has had a huge number of great positives, but as we've seen, it can also have some significant negatives, false information, actually disrupting the whole journalistic industry, newspapers, radios, television, because people are going to a different medium now. and ultimately will have disruptive effects on just about every occupation, so you'll have to adjust to it. So some of them can have some very negative impacts, and that's going to be true of any technology, airplanes, cars, whatever we've come up with in the past. And so again, the politics are an important part, being able to find ways to work together at the community level, at the national and then the international level, to try to put regulations in place that can control some of these major problems that can spring up from technology.
Also, obviously, we always talk about the world and all that, and how technology is affecting the entire world. What do you envision for San Diego and its future?
Well, San Diego, other than we have a cost of living problem and a cost of home problem, and so people, a number of people have to move elsewhere, and the homelessness issue. So we have some very significant issues to deal with. Having said that, I see a very bright future for San Diego. We've got very strong biotech industry and very good research ongoing in a variety of different institutions here. And so that's going to continue to be an area of significant growth. With still lots to learn there and lots to apply. And so biotech, I think, will continue to grow significantly. And then, of course, the communications industry and electronics, computer aspects, software. I think all of these are going to continue to expand significantly here, as long as we continue to have some very good educational institutions. And so I think the program that was put together in California way back in the 60s, of having very strong university system, state college system, community college system, and hopefully support some areas below even the community colleges for learning particular trades. I think we have that here in San Diego in a strong way. And so I think we're in a position to continue to develop the workforce we need to support the growing industries. And I think you can see that people, even though people leave here if they don't have a well-paying job, which is very unfortunate, people who are in some of the professions that can come here and work in biotech or communications or software are moving here because even though we're expensive, we're less expensive and more desirable than other locations. With the climate change, we happen to be in a very lucky location. I think most of the predictions on what's going to be happening over the next several decades are terrible until we hopefully can do more about it or find some engineering approaches that don't cause even worse problems to help it. But San Diego will continue to have a more moderate climate, and may have to go to desal and other energy intensive approaches to continue to get the water we need. But I think we're in a good position from that point of view. So we moved here from Boston in 1966 and have never regretted it.
Real quickly, what do you see as any sort of difference between East Coast engineering culture and West Coast? West Coast, we have Silicon Valley. East Coast, there's kind of the research belt. What are the main differences in the way that people go about engineering?
Well, it used to be very different in that there weren't very many startups on the East Coast compared to what was happening here on the West Coast. I think that's changed. I think everybody sees the value of trying to come up with a new idea. Let's go out and run with it, see if I can do that in my own company or with someone else, and get new things happening. We ourselves have helped in New York City. The mayor there a number of years ago was interested, how did they get a startup culture similar to the West Coast around New York City. And so they put up an offer of $100 million plus land to start a new institute. So we helped get Cornell and Technion together for working, because Israel has come up with a large number of startups, as you know, startup nation type work, and a lot of those people have come out of Technion. So anyway, so that's growing in New York City, and I think New York is getting large numbers of startups, and certainly a significant biotech as well as financial area. I myself prefer to see less financial engineering than goes on there, but so be it. But some technology advantages. I think other areas are recognizing the value of supporting a good research institute and university, and trying to attract people and keep the graduates nearby. So that will happen. I think politically we shouldn't try to make decisions by region other than, for example, putting infrastructure into areas that are economically depressed and need some work, so emphasizing those regions. But as far as research programs and so on, I think they ought to go to the talent, where the talent might be, but encourage people to train that talent, as I mentioned earlier, in a variety of locations. So again, I think San Diego is well placed, and we'll see how this all goes ahead. Good luck with your programs, and it's going to be interesting to see what influence you might be able to have on young engineers, young scientists, maneuvering through this very rapidly changing field, but one with lots of changes that each one gives an opportunity. So if there's a change, an opportunity comes along with it. And so keep an eye out for those. So wishing you the best luck with the program.
Thank you.
Dr. Jacobs, personally, I really appreciate you coming on and sharing all your wisdom. It's going to go a long way for everybody who views this podcast. I really appreciate it.
Thank you very much, Jeremy, and
Thank
good
you.
luck with your program. Same, Victor, and
We'll figure out a way to work together more in the future.
Super.
I got a bunch of ideas for you.
Very good. Take care.
All right, have a good one.